Have you ever wondered how we can satisfy as many children as possible with a limited number of cookies? Well, that's the essence of the assign cookies problem. Imagine this. You have an array of children's greed factors. These represent the minimum size of a cookie each child will be happy with. Then, you have an array representing the sizes of cookies you have on hand. The trick here is that each child can only have one cookie. Now the challenge is to figure out how to distribute the cookies so that the maximum number of children are satisfied. That means each child should get a cookie that meets or exceeds their greed factor. And remember, we're working with a limited number of cookies. Sounds challenging, right? But don't worry, we have a clever solution approach for this problem. The first step in our solution approach is sorting. This involves rearranging both the greed factors array, which we'll call G, and the cookie sizes array, or into ascending order. But why do we need to sort these arrays? Good question. Sorting ensures that we allocate cookies to children in an efficient manner. By satisfying the children with the smallest greed factors first, we ensure that we get the most use out of our available cookies. Imagine you have a small cookie and a large cookie and two children, one with a small appetite and one with a large appetite. If you give the large cookie to the child with the small appetite, the child with the large appetite will be left unsatisfied. But if you give the small cookie to the child with the small appetite, both children can be satisfied. Now that we have our sorted arrays, we are ready to start the allocation process. Let's dive into the heart of our solution, the main loop. This is where the magic happens. But first, let's set the stage. We need a counter, let's call it C, initialized to 0. This will keep track of all the content children. We also need 2 pointers, I and J, both set to 0. These pointers will help us navigate through the arrays AG and S, respectively. But what if there are no cookies to give? That's our edge case. If the length of a race is 0, it means we don't have any cookies. In this case, we return 0, because sadly no child can be satisfied without cookies. Now, let's get to the main loop. Here we iterate through the arrays using our pointers I and J, while there are still children to check. We compare the current child's greed factor, represented by G, with the size of the current cookie, represented by S. If the child's greed factor is less than or equal to the cookie size, it's a match. We assign the cookie to the child. This means we increment the counter E by 1 and move to the next child and the next cookie by incrementing I and J. But what if the cookie is too small? If the child's greed factor is greater than the cookie's size, the child won't be satisfied. In this case, we leave the child waiting and move to the next cookie by incrementing J. We do this in the hope of finding a larger cookie that can satisfy the child. At the end of the loop, we return the counter CE. This number represents the maximum number of children who can be made content with the available cookies. And there you have it. By efficiently iterating through the arrays, we maximize the number of satisfied children. This approach, by prioritizing smaller greed factors first, ensures that we make the most out of the cookies we have. Remember, the key lies in sorting the arrays and efficiently managing the main loop and edge cases. So what did we learn from the assign cookies problem? In essence, we tackled a classic resource allocation problem using a shrewd and efficient approach. We implemented a greedy algorithm which is adept at maximizing output under constraints. This algorithm prioritizes satisfying smaller greed factors first, ensuring more children get cookies. A pivotal part of this strategy is sorting. By arranging both the greed factors and cookie sizes in ascending order, we set the stage for an efficient allocation process. This way we ensure that the smallest cookie goes to the least demanding child, and so on, until we run out of cookies or children. We also examined an edge case where no cookies are available. In such a scenario, no child can be satisfied and we simply return 0. Our solution efficiently iterates through both arrays, matching children with appropriate cookies and incrementing a counter to keep track of content children. And that's how we solve the assign cookies problem, maximizing the number of happy cookie-filled children. Thanks for watching.